In this note, we'll discuss learning target number 5, determining the percent composition of a compound. Being able to identify an unknown compound is an important skill to have as a chemist. This can be used to identify new medications from natural sources, pollutants in the environment, or gathering forensic evidence. The first step in identifying an unknown chemical is to determine which elements make up the unknown compound and in what ratio. This technique uses the law of definite proportions as stated by Joseph Proust. He figured out that elements in a compound have fixed proportions by mass, which can be used to identify chemicals. The mass percent of an element in a compound is calculated using this equation. You take the mass of the part that you're interested in, usually in this case it's elements, and divide it by the mass of the whole compound and times it by 100. Each chemical has a unique set of mass percents for its elements, and you can identify chemicals based on these percentages. For example, if you have a sample that is 42.88% carbon and the rest is oxygen, then you know you have carbon monoxide. If you have carbon dioxide, then the percentage of carbon is 27.29%. The term percent composition just means you have a list of the mass percents of each element in a compound. For example, the percent composition of C8H8O3 is shown here. There are a couple of different ways that you can calculate percent composition. First, you need to do some sort of experiment if you have an unknown compound to figure out what types of elements are in there. We'll discuss some of these experiments in a later lesson. Example 1 shows you some experimental data and asks you to calculate the percent composition. Let's start with the magnesium. I take the mass of the magnesium, 22.69 grams, and divide it by the mass of my whole sample, 38.72 grams, and then I times it by 100. This gives me 58.60% magnesium. I can have 4 sigdigs in this answer. Now to find the percent of sulfur, I could do the exact same thing. Although sulfur is the only other element in the compound and will make up whatever's left over in terms of the percentage. So I can just take 100% and minus the percent of magnesium, 58.6, and that will give me sulfur. Since I've listed all of the mass percents for the elements individually, this is known as the percent composition. If you know the identity of the compound and have its formula, you can also calculate the percent composition. You would do this if you suspect a compound to be a certain type and you needed the correct answer to compare your experiment with. Example 2 has us calculating the percent composition of iron 2 bromide. Because this is not an experimental calculation, we get our masses off of the periodic table. If I'm calculating the percent of iron in iron 2 bromide, I would take the molar mass of iron, 55.85, and divide it by the molar mass of the whole compound, an iron and 2 bromines. That equals 215.65, and then times it by 100. I'm able to keep 4 sigdigs in my answer. I could just take 100% minus 25.90 to get the percent of bromine, but I also want to demonstrate to you the regular plug in the equation way. I would need to take the mass of 2 bromines because there's a Br2 in the formula. 1 bromine is 79.90, so I just times my numerator by 2. Divide it by the molar mass of the whole compound, and I can keep 4 sig digs in my answer. Although you can identify an unknown compound based on its percent composition alone, it is a little tricky. You have to have tables showing the percent composition of every known chemical, and you have to weave through them to try and find one that matches your experiment. And that's also assuming that you have no experimental error. Calculating the percent composition is the first step in the method that we're going to use to identify unknown compounds. In the next lesson, you'll learn step number 2. Try out the percent composition questions listed on your assignment checklist.